Welcome once again, ladies and gentlemen, to our science class. Anyway, I hope you're all having a good day and that you are not way too bored out of your mind in your beautiful homes. I know for some of you, early summer break was a dream come true. I understand that. And anyway, I hope you're having fun. I hope you're keeping up with your work. Let me say this once again for those of you in 7th and 8th grade. Science, science, science. I have not received work from some of you. I don't know what you guys are doing. I don't know, maybe you guys are out working. Sorry, I had to take a drink out of my juicy juice. 100% juice, no added sugar. I'm doing a diet. I'm getting fat again. Being at my house eating all this food is driving me crazy. Well, hopefully this won't last too long and we'll go back to normal soon. But anyway, as I was saying before I was so rudely interrupted, some of you have not turned in your work. You know who you are. You know who you are. I do not want to call out your name. But if I don't get your work this week, your picture shall be plastered all over my videos so that you know who you are. And so that everyone else does too. So let's get our work in, please, and we shall have a great time, or at least I will. Okay, so today we are looking at chapter 5 in our oceans book. Now I know you don't have the worksheet for this lesson, but you will get it soon enough. It will be emailed to you or to your parents, and you will be able to work on it. Today we're going to, this is what we looked at the last time. We were talking about the continental drift theory. We talked a little bit about this. In particular, we were looking at the composition of water, the composition of the ocean's water. And we talked about the elements of the oceans. Primarily, we focused on the element of salt, the beautiful sodium that we all love in ocean water. I told you I do not like ocean water. I would rather a nice, beautiful river with water coming down from the mountains, making sure that it is nice and clean, right? Maybe, unless somebody is doing something upstream that we will not mention in this video. All right, so we talked about that in chapter 4. So by now, you should have turned in 2.2, 3.1, 3.2, 4.1, and 4.2, I believe. Yes, you should have turned all of those in by now. If you have not, thou art late. Thou art late, and thou shalt be in a heap of trouble, my friend. And so make sure you turn those in as quickly as possible. And like I said, I will email to you 5.1 and 5.2 in just a little bit. So be looking for those. All right. So today we're going to be looking at, we talked about the salinity of water. And we talked about this as well. We mentioned the fact that there are several places around the world where we have a great concentration of water that is water. Sorry, a great concentration of salt. That's what I meant. And so we are looking at that. Okay. So anyway, all right, so let me erase this. We looked at that the last time. All right, great. This time we are going to be looking at, let me see now, let me get rid of this. We're going to be looking at tides, waves, and currents. three major movements of the oceans: the tides, the waves, and the currents. Now, in this video, we are only going to be looking at the tides and the waves, and in the next one, we will focus on currents. Okay, so just keep that in mind. All right, let's continue. First of all, let's talk about the tides of the ocean. What are the tides? Tides are the rise and fall of sea levels caused by the effects of the gravitational forces of the moon, the sun, and the earth. Okay? And as long as man has gone to the sea, he has been fascinated and also frightened by the powerful and restless bodies of water, right? And a lot of people, we enjoy those people who are romantic, hopeless people. They love going to the beach and sitting there and watching those waves and watching the tides rise and fall and all of that. And yeah, that's not for me. Anyway, but people love looking at the oceans, and specifically, they love taking advantage of the tides. Now, we're going to be looking at the tides, and there is a difference between the tides and the waves. So keep that in mind. Now, so tides are the rise and fall of sea levels caused by the effects of the gravitational forces of the moon, sun, and the earth. So make sure, please, you are writing this down. Okay, write it down. All right, let's continue. Now, there are two types of tides in the oceans. Obviously, the first one is high tide. High tide. And that is when the water advances to its furthest extent onto the shoreline. Okay? That's when you have to pick up your little beach chair and move further inland because the water or the waves and the water is coming up to your kneecaps and you're about to drown. Okay, so that's the high tide. Now, the low tide is when water recedes to its furthest extent. So, in other words, it pulls back into the sea. Okay, so two types of tides. Tides. I think I'm saying that right. I have an accent. Excusez-moi. All right, now, some of the greatest tides in the world are found in our neighboring country to the north, Canada. Oh, Canada, my home, sweet home. I have no idea what else it comes after that. But anyway, the largest or the highest tides in the world are found in the Bay of Fundy. The Bay of Fundy. And that bay is found between the state of New Brunswick, or the province of New Brunswick, and the province of Nova Scotia, or New Scotland, for those of you who are of Scottish descent. And it is in this beautiful place where you will find that the tides in this place are the highest in the world, and they can rise and fall almost 53 feet twice a day, every single day. And oceanographers have studied and have basically come up with a formula to measure how many tons of salt water it takes to make these tides in this Bay of Fundy. It's almost 254 billion tons of salt water that make its way in and out of that bay with enough force to spin a battleship. And so you see the arrow there. The ocean water is pushing into that bay and creating those huge tidal waves. And like I said, they are the highest in the world. Now, these waves or these tides, not waves, tides, are also found in other places around the world where the place has truly become famous because of it. One such place, oh, by the way, this is a picture of the Fundy Bay. The Fundy Bay. There you can see where the people are down here. Let me see, down here. This is at low tide, and this other picture over here, it's at high tide. Okay, so you can just tell the great difference in the change of the water level, and this happens twice a day, every day. Anyway, another place where this happens and has become very famous for tourists is this area right here, Mount Saint Michel. This is in the area of Normandy, in the beautiful country of France. Okay, La French, France, right here. Okay, and actually, this is one of the places where during World War II, the D-Day or the Normandy invasion happened in this location. Okay, it happened in this area right here. Okay, so yeah, the French are lovers, people. They are not fighters. That's why we had to bail them out of World War One and World War II, but we won't get into that today. And one of the beautiful places in that area of Normandy is this mount called Mount Saint Michel. It was an old medieval castle, and one day when I win the lottery, ching ching ching, I will buy that place. Yes, look at that. That is beautiful. Now this, the picture at the corner here is Mount St. Michel at low tide. Okay, and then the larger picture there is at high tide. And you can tell, I mean, if you wanted to have a kingdom, right? A place that would have natural protection, this would be the place for you. And so there are a lot of tourists that go here every year, and it is just famous because of the fact that you have the low tide and the high tide, and when the high tide comes, my friends, sometimes there is no way for you to get to this place. In fact, there are times when the high tide is so high that this area right here, this whole area right here, the land bridge that's there, usually will disappear, and there will be no way for you to get to that place. Okay, but look at it. This place is so beautiful. I want to go there. I want to go there. In fact, I want to buy it. So just remember, when I own the place, you are all welcome to come and partake of the beauty of my beautiful island. Here we go. Here's another picture of it. Let me see. Let's go back. I don't even know what I'm doing. Here we go. Okay. Okay, there we go. Hey, hold on. I don't even know what I'm doing, people. Here we go. Oh, nope. Let's go back. One more. I'm sorry. I'm having a hard time with this. All right. Next. Okay. Here we go. Man. All right, so that's one, that's two, and well, anyway, that's it there. All right, so let's continue. Now, what causes the tides? What causes the tides? Now, there are two main causes, actually three that I mentioned at the beginning, but two of them are the primary ones, okay? Two of them, the primary ones. And the two main causes are the gravitational pull of the moon and the sun. Now, because of its proximity, the moon has twice as much effect on the tides as the sun. And so today, scientists, oceanographers, are able to predict tides based on the motion and the location of the sun and the moon. And so this is the way that we find out, or we know when high tide and low tide will be. Okay, and so the stars, so the moon's force, because it is twice as much as the sun's, in spite of the sun's incredibly huge mass, it has a higher or a higher effect on the tides as the sun. Also, the stars and other planets do have some gravitational force on the Earth, but because they are so far away, that force really has no effect on how the tides of the Earth work. Now, how do they work is the question, right? How do they work? And so, now let's look at this diagram here. To understand how the tides work and the gravitational pull of the moon and the sun effect, we first need to consider the impact of the moon's pull on the earth. Okay? Now, the moon's gravitational pull causes the water to bulge out on the side of the earth closest to the moon. Now, you see the moon's gravitational pull there by that orange. What is that thing? An arrow. That's right. Thank you. Now, what happens here is that the bulge creates higher water levels on the side affected. Okay, so we will have the bulge of water. We will have it. Let's see. We will have it. Let me pick a color here. Here we go. Here's the bulge of water here, and then we will have one here as well. Now, this creates higher water levels on each side. Now, when we consider the mass balance of the whole Earth system, okay, the center of the Earth's mass, it's obviously at its core, like right in the middle, right there. Now, when we add the moon or the gravitational pull of the moon, it actually causes the Earth's center of mass to move. Okay, so the center of mass moves towards the side of the Earth closest to the moon. And so it'll move that way or shift that way, depending on where the moon is, okay? It'll shift that way. Now, what happens is that the water on the side of the Earth away from the moon receives a smaller gravitational pull from the Earth. Now, because the center of the Earth has not, or the centripetal acceleration, it's called, has not changed. What happens is a bulge of water forms on the side away from the moon as well. So this one here, okay? So we'll have the gravitational pull pulling that direction here, and it will also cause a bulge on that side right there. Now, since the total amount of water stays the same, right? The amount of water in the ocean stays the same. Higher water levels on two sides or on the two sides are balanced by lower water levels between them. So as the gravitational pull of the moon pulls that way, we have low tides here and low tides on that side. Okay? Now, all things then being equal, this would mean that that at any point on the earth you would experience two high tides, one for the side toward the moon and one for the side opposite the moon. And you would also experience two low tides, and the two sides with the lower water levels between the bulges each day. So that would be this one over here and that one right there. Okay? And so the amount of water obviously stays the same, but the high tides and the low tides are affected because of this little guy right here, the moon. Okay? Is the moon a girl or is it a boy? Because in Spanish we call it la luna, making it feminine. But in English it's just the moon. Anyway, we'll leave it there. All right, well, maybe it is a girl, right? Because girls are smaller, and the guys right here, the sun is the sun, el sol. So the sun is macho, it's a man. So yeah, I guess the moon is a girl. Anyway, sorry girls. I don't want to offend you or anything, but that's just the way it is. Now, let's continue before you girls get all upset at me. Next, let's see the next one here. Now, let's continue with this. Then, let's see. All right. Now, there are also other types of tides that affect or are affected or that are produced, let's put it that way, by the gravitational pull of the moon and the sun. Now, when we consider, we have the pull of the moon, and then you also have the pull of the sun. Now, during the new moon, the gravitational pull of the sun will be on the same side as the moon. Okay, so we see that right here as well. Okay, we see that right here. Here's the new moon, and the new moon and the sun are on the same side. Now, during the full moon, the sun is pulling from, oh, I'm sorry, that's the new moon. This is the full moon right here. Sorry, I don't know how to read. Let me erase this one. There we go. That's the new moon right there, or the full moon. Now, during the full moon, what happens is that the sun is pulling from the opposite side of the moon. At both of these times, the pull of the sun adds to the pull of the moon and creates higher high tides and obviously lower low tides as well. Now, these are called spring tides. Okay, so whenever you have during the, and this does not necessarily mean that these happen during the springtime. Okay, that's just the way they're called, and they're called spring tide here and here because of the way that they jump, or the difference in low and high tides. Okay, there's a greater difference. Now let's continue. Now, when the sun and the moon line up this way, there is a name to it, and it is called syzygy. Syzygy or syzygy. Let me spell it for you. It's SYZYGY. Syzygy, I believe it's pronounced. Now, when the moon, so that is at spring tides, okay? The sun is on one side and the full moon is on the other side. And so that will produce the spring tides, okay? That is one of the tides that we have, the high tide and the low tide. But we also have what are known as spring tides. Now let's continue. Alternately, also, whenever you have the sun and the earth and the moon, when all three form a 90-degree angle, we have what is known as a quadrature. And that would be right here, and here. Okay? Here we have the right angle right there. Or it could also be here and here. And this is our right angle right there. Okay? Now, when that happens, at that point, what the sun does is that it counteracts the impact of the moon, so that we'll have lower tides, and also we will have lower high tides and higher low tides. And so these are called nip tides. All right, so that setup there of the 90-degree angle between all three of them will produce a nip tide. And a nip tide, you will have low high tides and high low tides. All right, so these are the types of or how the location of the moon and the sun affects the tides of the earth. So it's very interesting. In your book, you'll have a little bit more of a explanation on it. And on page 34, I believe it is, you will see an example of the nip tide and the spring tides and how they are set up in this form, okay? So whenever you have a right angle between the sun, the earth, and the moon, you will eventually have nip tides. And when they line up, all right, in a 180-degree line like this, okay, you will have spring tide. Okay, great. Now let's continue. You will read more about that in your book as well. All right, let's continue on. Now, let's talk about the waves of the ocean. The waves of the ocean. Now, the waves of the ocean are formed. The waves of the oceans are formed by winds disturbing the top layer of water. Waves are motions that carry the energy of the sea, okay? And in your book, they'll give you an example, or they will they'll give you an example or an illustration, just kind of basically laying that truth out, that waves are motions that carry the energy of the sea. And really, the waters themselves do not move so much, and it's really more of the wind moving and disturbing the top layer of the water. Now, one such example of these waves or energy being moved through the ocean, though the top layer of ocean water being moved by the energy, are tsunamis. And tsunamis is the Japanese word that means harbor wave. Harbor wave. And there are several waves that tsunamis can occur or can take place. And here they are. Okay, tsunamis can take place really anywhere around the world, but they are formed, or they occur when you have large movements of the ocean, and they are caused by different events, such as underwater landslides, hurricanes, volcanic eruptions, underwater faulting from an earthquake, and even a meteoroid impact can produce a tsunami. Now, we haven't seen one of those in a while, so those are very, very rare. But if a meteoroid were to hit, a good-sized meteoroid were to hit the ocean, it would create a tsunami. Now, primarily though, they happen when you have a movement of the tectonic plates of the earth, and that causes the subtraction that we talked about in the last class, the tectonic plates moving and causing friction between one another. That will cause an earthquake underneath the ocean's waters, and it will create a tsunami. Now, if the earthquake is severe enough, I mean, we're talking about it would have to be like 7.0 on the Richter scale. It could possibly result in a tsunami that can travel at speeds of up to 500 miles per hour. And okay, that would be in the open sea. And that also would depend on the depth of the water. Now, a tsunami can pass under a boat in the ocean, in the open ocean, without notice. So, you can be out in the middle of the ocean, an earthquake take place underneath you, and that tsunami gets started, and you would not feel a thing. Now, scientists, as you'll read in your book, use seismographs to pick up the seismic sea waves produced by an earthquake. And they can determine where and when that earthquake started. And so, although a tsunami becomes unnoticeable as it spreads out, it becomes destructive when it gets near the shore, okay? And that usually happens because the friction that energy has is it causes friction with the bottom of the sea, and so it kind of slows it down, and what happens is that the water starts to pile up, and that's when you get those huge waves that are pretty much associated with tsunamis. Tsunamis have been around for a long time, and they are very, very destructive. Very destructive. For example, in the year 2004, out in the Indian Ocean tsunami, it actually started right off of the northern coast of Indonesia, the island of Sumatra, this island right here. All right, and there was the epicenter. And that tsunami, okay, that earthquake, if I remember correctly, was a 9.0 on the Richter scale. I mean, if that thing would have happened on land, it would have destroyed everything for miles. Now, this thing actually affected, if you see the map there, there's almost 14 different countries that were affected by this tsunami. The waves were felt in all of Southeast Asia, and they were felt as far away as Somalia, Kenya, Tanzania, Madagascar, and South Africa. Now, the only reason why Mozambique, this little part right here, this is Mozambique, the only reason why Mozambique was not affected was because the waves, instead of hitting Mozambique, they hit Madagascar. That's where those beautiful animals of Madagascar, that's where they landed in the first movie, right? And that's where King Julian lives there. Anyway, so yeah, King Julian's home island actually protected Mozambique from getting destroyed and feeling the effects of this tsunami. But there were thousands of people that died during that tsunami back in 2004. Japan is famous for these tsunamis. And I believe the last one was in 2012, 2014, around there. A huge tsunami hit the northeastern coast of Japan, destroying a lot of places. This is a picture of that tsunami in India, that 2004 tsunami. This is part of India, and this is the waves hitting the coast. Here you have the waves in Sumatra, basically destroying everything in its path. And so, yeah, this is not, I mean, everybody likes the coast. But when I look at pictures like these, I say, nope, I'd rather stay inland. Thank you very much. This is another picture. This is after the fact. These tsunamis are, like I said, they can reach up to 500 miles per hour in the open sea, and they can reach way, way inland, okay? For example, in 1946, in Alaska, there was a tsunami with waves of over, over 100 feet, okay, 100 feet high. One of the lighthouses that was there in one of the islands off the coast of Alaska, the lighthouse, it was a 5-story lighthouse, okay, and it sat 90 feet above sea level. That thing was completely covered with the waves of that tsunami. More than 100 feet high, the tsunami in 2004, man, I can think, reached also 100 feet high, the waves in the coast, and it was traveling at almost 50 miles an hour. Okay, that is a lot. In some places, the waves or the water reached inland about 1,000 yards. Okay, so that's what? That's 10 football fields from the shoreline inward. and by the time they got to 100 yards, some of the waves were still 30 feet high. Okay, so yeah, tsunamis are not something you want to mess around with. Now, the most cataclysmic account of the forces of water described in the history of mankind is found in the book of Genesis. The Bible says in Genesis chapter 7 and verse 11 that the same day were all the fountains of the great deep broken up. That is a reference to an earthquake or earthquakes taking place underneath the ocean water that broke up the crust of the earth into the tectonic plates that we have now. And that is how, or one of the reasons why the earth filled up with so much water. The 40 days and 40 nights of rain are mentioned second, but the first thing that is mentioned is the massive seismic earthquakes that were caused by the fountains of the great deep breaking up. And so that generated what we would know today large tsunamis. And so those waves were large enough to create all the havoc and allow the water to run out into the land, the dry land, the way it did. And so tsunamis have been around for a long time, and most likely the first ones took place during the Noah's flood. All right, let's see, let's continue. All right, we're gonna leave it there for today. And so just a little bit of information on tides and waves, okay? Tides and waves. And so in the next video, we will look at the currents, okay? But for today, just remember that tides are the rise and fall of sea levels caused by the effects of the gravitational forces of the moon, sun, and the earth. And that the waves are formed by winds or the winds disturbing the top layer of water, and it's basically what you see out in the seashore is the motion that carries the energy of the sea. Okay, all right, so we'll leave it there for today. Now remember, you love me, and I will send you work. So when I send you the work, don't be getting all flustered and everything. Make sure you read the chapter. I am just giving you bits and pieces of the information here, but you need to read the chapter and answer the questions, the worksheets for 5.1 and 5.2. All right, so, and when you get done with it, you must be done with it by this Friday, okay, by this Friday. And we will be, this Friday is going to be, let's see, April the 3rd. April the 3rd. All right, great. All right, guys, it was a pleasure for you to listen to me. And just in case you missed seeing my beautiful face on this video, here I am. Ta-da! Look at my beautiful face. That face was chiseled by angels in heaven. Anyway. All right, guys, we'll talk to you later. Make sure you get your work done, and we'll see you in the next video. Bye.